Okay, so now we're looking at subtraction again, and we have x minus 4 and an x plus 4. So we have different denominators. We need to come up with that common denominator. So I'm going to multiply 4 on this side, x minus 4, and on this side, x plus 4. You need to make sure you're leaving yourself lots of room because these are going to take up more room than usual. All right, on this side, we get x plus 4 and x plus 2. On the bottom, we get x plus 4 and x minus 4. Minus. Now, because of that minus, we've got to just make sure we're real careful. We can't lose sight of that minus. I'll show you what I mean in just a second. Now they have common denominators. So what we're going to do is we're going to put it all across here. And we have x plus 4, x minus 4 for the denominator. X plus 4, x plus 2 minus, and then making sure we don't lose that minus there. Now, in order for this to work properly, we're going to have to multiply because there's nothing we can take out of these here. But if we multiplied these in a box, we could combine the like terms and see if something happens. So we're going to make some boxes again. So over here, I'm going to make a box. And this time we're not factoring. Everything's factors for us. We actually have to do the multiplication just to kind of clean up our problem. So here I'm going to do x plus 4 and x plus 2. Remember, these two share the 2 in common. These two share the x. These two share the x. These two share the 4. And we get x squared, 2x, 4x, and 8. So on the left part of this here, I'm just going to put that subtraction in the middle, we have x squared plus 2x plus 4x plus 8. Now, box for this part. Don't worry about the negative right now on this side. When we get to that, I'll tell you what you're supposed to do. So here we have x and a 1 and x and negative 4. So these two share the minus 4. These two share the x. These two share the x. These two share the 1. So x squared minus 4x plus a 1x minus 4. So now we write all that down. We're going to put parentheses because this negative is saying subtract everything on this side. So we have to separate that out. X squared minus 4x plus a 1x minus 4. All over x plus 4, x minus 4. Big problem here. We're doing a good job. So now we're going to distribute this negative, and then we're going to collect our like terms. So let's do this. X squared plus 2x plus 4x plus 8. And we have negative 1 times x squared, negative 1 times negative 4x, negative 1 times x, negative 1 times negative 4. It's all the top. And the bottom is still the same. X plus 4, x minus 4. Okay. Let's put that in there then. X plus 4, x minus 4. Now we got to get rid of all those parentheses. I'm going to go ahead and add these two together because I can. 2x and 4x would give me 6x plus 8 minus x squared. Two negatives make a positive 4x minus x. Two negatives, positive 4, all over x plus 4, x minus 4. Now we have to collect our like terms. Look, here's an x squared and a negative x squared. 1 minus 1 gives me 0. Here we have a positive 6, a positive 4, and a negative 1. 6 plus 4 is 10. Minus 1 gives me 9x. 8 and 4 positive gives me 12, and we get x plus 4 on the bottom, x minus 4 on the bottom. I can take a 3 out of both, but I'm still going to get 3x here, and that's not going to help us. So that is our final answer. So we saw another one like this earlier. Remember, when there is no fraction, there's no number on, no denominator, pardon me, you can always add a 1. And we don't need to multiply this side by 1 because 1 times anything is itself. So we're going to multiply this side, though, by 1 and represent it as x plus 4 over x plus 4. So now, we'll just do down here, 3 times x plus 4. 1 times x plus 4 is just x plus 4. Now we have common denominators, so x plus 4 is our common denominator. Here I'm going to distribute 3x plus 12 minus 3, don't lose that minus 3, 3x, and then 12 minus 3 is a positive 9. If I remove the 3, so 3 times x plus 3 times 3 over x plus 4, what I'm going to get is 3 times x plus 3 over x plus 4. If I could see that, I can leave it here. If I don't see it, then I got to take it here to make sure it's okay. Now we're looking at least common multiple. And when we're looking at a least common multiple, this is another way you can attack these problems. When they get a little bit more involved, then you can go with what's the least common multiple, and then you can actually factor each expression and then form the product using each factor, the greatest number it happens. Let me show you what that means. So I'm going to factor this, and I'm going to do a factor tree. And when I do a factor tree, what I do is I say, okay, what times what equals this? And I'm going to do 8 times x squared y squared. Then I say, okay, what times what equals 8? 2 times 4. As soon as it's prime, I can no longer split it up. I circle it. So I see, oop, I can't do anything else with 2. I could do 2 times 1, but that's still 2. So now I've got 4, and 2 times 2, boom, good there. I'm going to split these up to x squared and y squared, and I know I can split this to x, and that's as far as I can take them. And this is y and y. And that's as far as I can take it. Now looking here at this problem, I split it up to negative 12x y to the third. Split my negative 12 up. I'm going to make it negative 1 times 12. Get rid of that negative. And then 3 times 4. And 4 is 2 times 2. As soon as I can't go any further, I can't factor it out anymore. Just like 3 was as far as I could go, I circle it. And then here I get x, which is done, and y to the third, y and y squared. You only do one at a time, and y and y. All right, so on this side, I'm going to put 2 times 2 times 2, and x times x, y times y. Over here, negative 1 times, I'm going to put 2's first. So 2 times 2, 3, there's 1x, and there's 3 y's. All right, so you want the greatest number it happens. So here there's 3 of them. Here there's only 2. So we need 3, y to the third power. Okay, that's done. X, well here's 1x. This one has 2, so the greatest would be the x squared. So my x's are done. This one doesn't have a 3. This one has a 3. So I have to use the 3. I didn't put my little multiplication dots there. This one has 2 2's, but this one has 3 2's. So I need all 3 of my 2's. And then I'm left with that negative 1. So now I have 2 times 2 times 2. Now 2 times 2 times 2 is 8. Times negative 1 gives me negative 8 times 3 x squared y to the third. And when I multiply that, I get negative 24 x squared y to the third. And that's a long thing, but the least common multiple is negative 24 x squared y to the third. If I was asked to find the least common multiple of these two, I would have to have multiples. And if I try to break this off, I can't because these are addition and subtraction. The way we find multiples on these is through the box. So I'm going to take this and come up with my multiples. So this is the x squared, and this is a minus 6. Okay. X squared is x times x. Now I need something that multiplies together and gives me negative 6, so when I add it, I get a positive 5. I'm thinking 6 and negative 1. 6 times negative 1 is negative 6, but if I add them, I get a positive 5. Bring that negative 1 up. These two have to share the x. These two share that x. And these two share the 6. Here I get negative 1x. Here I get a positive 6. And when I add those together, I get a positive 5. So this one's two factors are x plus 6, x minus 1. So now if we factor this side, we say here, the x squared goes here, and the negative 1 goes there. Okay, oops. All right. To get the x squared is x times x. The only way to get negative 1 is negative 1 times 1. Follow these, share the same 1. These share the same. These share the same. And these share the same. So I get a positive x and a negative x. When I add those two together, I get 0, which is what I needed. And so the factor on this side is x minus 1, x plus 1. So now we look at the factors and we say, okay, we need the one where it happens the most. Well, x minus 1 happens on both sides, but it only happened once. So x minus 1, one time I need. This side has the x plus 6. And this side has the x plus 1. That one's real weird for least common multiple. But you just have to remember how to factor, factor, factor.